Okay? Then you get that, right? You do f of g, remember f of x, what is f of 5? Here's f, so what? It's the square root of 5, right? What is f of 1,000? It's the square root of 1,000, right? What is f of a? It's the square root of a, right? F is the square root of whatever, right? What is f of a plus b? Square root of a plus b. So what is f of g? The square root of this, right? Which is what we want. Right? Okay? All right. Now one thing to make sure of is that, notice that this is not equal to this. So if you switch and say one is the inside and one is the outside, you don't get the same thing. Right? You don't get the same thing. So this, you can't do this. You can't switch the order. Okay? All right? Okay. Now, so now that we understand the composition of two functions, now we said we were looking for derivatives of sums, derivatives of subtractions, derivatives of products, and derivatives of divisions. And now if there is a rule, it would be nice that if we could have a rule for the derivatives of compositions. Because that would enable us to take this function. Now if I asked you to find the derivative of this function, suppose this is f, or let's not use f, it's h. And I asked you, what's the derivative of h? You could do it, but you'd have to do a lot of work to do it. Right? Because you'd have to multiply that out times itself 10 times, then you'd have a long polynomial, and then you'd have to do the derivative of that, right? So you could do it, but it would take a long time. However, if we find some kind of rule, derivative for a composition, and we write this function, we break it down into the composition of these two, maybe it's going to be much easier. Okay, at least it probably won't be harder. Right? So, that's what we're trying to do here. So, we do have a rule for the derivative of a composition. The derivative of a composition, and it looks pretty simple. Okay, but it's not, doesn't look completely simple, because this part looks a little complicated. But this part looks completely simple. This is what? If you're doing the derivative of f and g, this piece here is what? Just the derivative of the inside function g. Right? So that's straightforward. And then what's this mean? This is a little confusing. But what this means is that you do the derivative of f, and then you put in g. Okay? So that's not that hard either. Okay, you do the derivative of f, but you don't put in whatever. You put in g. Okay, so the derivative of f is going to be some function, and then you're going to put g into that function. Okay? So it looks a whole lot easier than doing this. So let's work it out. So if we want to know h prime, that means we want to know the derivative of f of g, because that's what we mean by h. That's what we mean by h. But this rule, called the chain rule, says that all you have to do is what? Let's do the easy piece first. There are two pieces, one and another. Right? So let's do the right-hand side first. Means the derivative of g means the derivative of the inside function. So here's the inside function. Right? We already broke this down into these two. This is the inside. So that's why I asked you to learn how to go backwards. Because you have to break it up into a composition in order to use the composition rule. Okay, so So anyway, we want on the easy part is the g prime. So the derivative of this is easy, right? What is that? 4x to the, 5x to the 4th plus 2. Okay, that was very easy. Okay? And then we have to do the other part, which is here. So again, what this means is find the derivative of f, but then don't just put in x, don't put in whatever, put in g. So do the composition of f prime with g, right? Put in g into f prime. So what is f prime? So first we need to know what f prime is. So if that is f, if f is x to the 10th, then f prime is what? 10x to the 9th. But don't put in x, don't put in blah, blah, blah. Put in g. So put in g here, right? So I need 10, I'll just write it out. G to the 9th. And that's it. But of course we don't want to leave g there. But that was much shorter than doing it the long way. Okay? So what if we finish it, what do we get? 10. G is what? X to the 5th plus 2x plus 8 to the 9th times g prime. Okay? So that was so much easier than we would have had to do it. All right? And so that is so this is again just like part of our arsenal of tools for finding derivatives. Right? We need to find derivatives. We have a whole set of things we can do if we can find derivatives. And this adds to our set of tools that we can use to find derivatives. So now we can find a derivative of this, in a reasonable amount of time. Or even if it was this, suppose that, then we could never do it the other way. Right? But now we can do it just, it's just going to change by a tiny bit. Right? What's going to change? It's just going to be, this is going to be 1,000. And this is going to be 999. That's all that will change. Right? So, but, if you tried to do it the other way, you could never do it. Right? Okay, so now we have this new set of derivatives that we can find. New set of functions that we can find derivatives of. Right? Okay, so let's try one more. Well, let's try at least one more. So let's try, suppose we had a function age. Equal to e to the x to the 3rd plus 2x to the 5 plus 7. And we wanted to know the derivative of that. So I want to know what is the derivative of that. Okay, now, we don't really know what to do, but we go through the list. Well, could we use the product rule? Could we use addition? No. Could we use subtraction? No. Could we use multiplication rule? Probably not. Blah, blah, blah. Can we, because what we'd have to do is, can we make this into the sum of two simpler functions? I can't see how to do that. Can we make this into the product of two simpler functions? Maybe, but it's not really going to help us. We could do that. We could say this is e to the x to the 5th times e to the 2x to the 5th plus 7. Is that right or not? Am I thinking wrong? When we multiply things with the same bases, we add the exponents, right? So that would work. But that's not really going to help us. Because even this part, we don't know what to do with this. Right? Maybe actually. This is, e to the x to the fifth. Oh, that's a tricky thing, by the way. Is this equal to this? Is that true? No. These are not the same.
No, that's...
That caused me a lot of headaches. They're not the same, are they? Because this is what? E to the x times e to the x, right? 5 times, which is e to the 5x.
Yes.
Not that. Okay, so anyway, we can't really break this up into a product of two simpler functions. So the product rule isn't going to help us, and the quotient rule isn't going to help us. So maybe nothing will help us, but maybe we can, try and write it as the composition of two functions. That, if we can, then that will probably help us. So, but you know that you can, right? We've been practicing this. So what's the outside function here? I want to write this as f of g. So how could we do that? What's the outside function? And what's the inside function? Okay, is this making sense? Okay, so now these are probably easy to do. We're going to need the derivative of this one. If you go back to the chain rule and think about what you need to do, what do you need to do? You need the derivative of the inside one, you need the derivative of the outside one, and you just have to put the inside function into that derivative. So the calculations you have to do are the derivative of the outside one, the derivative of the inside one. You're going to have to do the derivative of the outside one, and you're going to have to put that first one, the second one, into that derivative. So that's all you're going to have to do. So that means we're going to need the derivative of this, also going to need the derivative of this, then we're going to have to do one more thing after that. Okay, so these are not, but those are easy to do. Right? What's the derivative? The derivative of f is what? Just e to the x, right? That was super easy. Right? And then we're going to also need the derivative of this one. What's the derivative of that? That's also super easy. Right? And then we're going to have to do one last complicated thing. That is put this into this. Right? The chain rule is going to require us to do that last bit of complication. Okay, but anyway, the chain rule just says that the answer is going to be the derivative of h, the chain rule says, is going to be what we just said, f prime of g times g prime of x, right? Okay, that's the chain rule. So, we already did that. We already did g prime, so we can put that here. Right? And then we have to do f prime, we already did that. But we have to put what into f? G. So the derivative of f is just e to the x, but then we have to put g into there. Right? So what do we get for this part here? E to the, not x, but e to the g. Right? So e to the x cubed plus 2x to the fifth plus 7 times this one. So that's this part times 3x squared plus 10x. Okay, so we got the answer. We wanted to know what's the derivative of this, And we couldn't use the addition rule, and we couldn't use the subtraction rule, and we couldn't use the product rule, and we can't use the quotient rule, the division rule. But we were able to at least break this down into a composition of two simpler functions. And then we can use the chain rule, the composition rule, because that's all we need to do is break it up into the composition. And then we can use this kind of thing. Okay? So now we've started with this function and we were able to find its derivative as what? Where is it? Here. Okay? That is the derivative of this. Alright? Okay, so now we know derivatives. Like how to do derivatives of everything you need to do. You don't need to do anything more than this in this course. And as I said, even like for neural networks, you know, the chain rule will get you basically everything you need. A little bit more, but not really. Basically, that's it. And we end up dealing with functions like e to the something. That's what they often use in neural networks. So we need to find derivatives like that, and this chain rule will do it for you. Okay? So if you want to study that, you should. There's one more thing you should study. That's like matrix algebra, which is very easy actually. It's not very complicated. But keeping it in your head is kind of complicated, but it's not very hard. So anyway, if you want to study that, if you want to study, you can take data science next semester. I think it's called data mining. And you can take programming next semester in Python, which is the one that I'm teaching. Nobody else teaches Python. And then there's another class, I think. Oh, I have another class, I think, probably called Special Lecture, where we'll do all of this from a sort of a non-mathematical point of view. So kind of just like using tools to do it. So anyway, you're welcome to take those. Okay? But in any case, we were able to find the derivative of this. Any questions about that? All right, so you should go back and review this and do it, you know, at least 10 more times. And the first 6 times, you'll probably get confused. Hopefully you'll get out of being confused. Sometimes when you do something, you get more confused, not less. So usually if that happens, you should stop and don't do it for a while, and then come back to it again. And if it happens again, stop again, and don't do it until you're not getting confused. Because when you're getting confused, you know you're going in the wrong direction, right? Because it's not that hard, right? You just have to find the right path, right? So if you're getting all lost, that means you're probably going down the wrong path. You should stop. Okay? So we have done the chain rule. Now, why is it called the chain rule? So the reason it's called the chain rule is, if I can get this right, let's say we have this function, y equals h of x, and we want the derivative of it, right? Okay, so it's going to turn out that we can write this, the answer, as something like this. Okay, now that's not clear where that comes from. But if I can write it like that, do you see why it might be called the chain rule? It's just like, you know, kind of things kind of being, well, there's another explanation for why it's called the chain rule. Suppose that well, we'll look it up on the internet, why it's called the chain rule. But it turns out that we can write the chain rule like this also, but that doesn't make any sense yet. So what I'm saying is, suppose that this is the case. U is equal to g of x, and this is equal to h of u. Okay, so what do I really have? I can put u in here. Maybe I shouldn't use h. Maybe I should use f. Yeah, let me do that. So what does this give me? If I put u in here, what do I get? F of g of x, right? So it's just separating out g, giving it another name, another variable, like it's equal to an intermediate variable. Okay? So it's just giving it another name, that's all. So we have y equals f of u, but u equals g of x, so of course y equals f of g of x, which is just what we were saying before. So what if we write it like that, then what happens here? Let's see if this works. What is this piece here? G prime is this, which is du dx. Right? That's du dx, right? Because because g is equal to u, so the derivative of g is du dx. Usually we write this as y, then we'd write dy dx, but I called it u, so I'll call it du dx.